So it looks to me like in the veneers that are chosen for the cases that the Spock's particular judge presided over, looks to me like there are way fewer women on those veneers than there are on the other judges' veneers, which should not be happening if all the veneers, if the veneer for each court case is a random selection of potential jurors, right? That should not happen. So perhaps there's something funny going on. Now let's think about why that might matter in this case. Why would it matter in this case? Why would we be particularly concerned about the fact that there might be something funny going on with Spock's judge such that there are fewer women available to be in his juries? Well, remember I said that Spock was a famous pediatrician who wrote books about child rearing, and at that time, most of the people reading those books were women. And so the women are the ones who are more likely to be sympathetic to Spock. They feel like he was their friend as they raise their children, right? They are familiar with his work. So there's this idea that women might be prejudiced in favor of Spock, more likely to think that he's a good guy. And so the fact that the judge that Spock was assigned to might be someone who keeps women off of his juries is certainly a big concern. So I like this question because it's a real data set, and also it is perfectly set up to compare the means of different populations. So we have 7 different populations here. Each population, so the unit of analysis here is a court case that has a veneer, right? And the number we're interested in for each unit is the proportion of women on that veneer. So there is a population of cases assigned to each of the 7 judges. Here in this box plot that we're looking at a sample for each of those 7 judges. And what we're interested in is whether the mean proportion of women and the population of veneers for each judge is the same. Okay, and this question is perfectly set up to answer that. Now, I think you can tell by looking at the box plot what's the answer going to be. Something funny is going on with Spock's judge, right? So I'm going to write that in the slides. I think that's important. You can see the answer. In fact, in many, many statistical problems, you can see the answer by looking at one graphic, right? And so often the hypothesis test is just sugar on top and perhaps not even necessary, right? Like you can, if you were trying to make an argument to somebody that there's something funny going on with Spock's judge, you're probably better off showing this set of box plots than presenting just a p-value. However, it's important to know how to do the hypothesis test as well. The visualization is not always quite so stark. And so we're going to use this example to motivate our discussion as we think about how to come up with a test statistic for more than 2 groups, to compare the means of more than 2 groups. Just to wrap around the Spock example, what actually happened in that case is that Spock was convicted, but then later that conviction was overthrown when they discovered that Spock's judge had done all kinds of unethical things, not even related to the juries. So the judge was a really bad guy. And so in the end, Spock was fine.